Hi everyone, this is Mrs. Musoff, and today we are going to learn how to solve a polynomial equation. Remember, solving means getting it to be x equals, right? And the way we're going to solve is actually by factoring. So we've been factoring for the last couple days, and we already know how to solve by factoring using the zero product property. So part of this lesson should be kind of straightforward because we've seen it before. It will still be a little more difficult because polynomials have higher degrees than a quadratic. All right, but let's warm up just by trying a quadratic. Wow. This warm up. Solve for x by factoring and then sketch the graph. Hint, check for a GCF first. Remember, we shouldn't need that hint. We always check for a GCF. In here, it looks like it'll be a 2. So 3x squared plus 11x plus 6. And remember, to factor a trinomial like this, we're just going to set it up into 2 parentheses and guess and check. Since this is just x squared, I know to just do x and x, technically 3x and x. And then 6, well, it could be 1 and 6. It could be 2 and 3, right? Couple different options. You can try them if you'd like, or you can trust me here that 2 and 3 are going to work, because that's 2x and 9x, and that's 11 if they're both positive. And then remember to solve by factoring. So this would be just factoring. Solve by factoring, I'm going to take each one of those factors, so the 3x plus 2 and the x plus 3, and I'm going to set them equal to 0 and solve. So I'll do that over here. Oops. 3x plus 2 equals 0. Subtract 2, and I get 3x equals negative 2. Divide by 3, and there's one of my answers, negative 2/3. Same thing with the x plus 3, set it equal to 0, solve, and there's my other answer, x equals, negative 3. Okay, the other part of this says sketch the graph, so we're going to use some of what we learned a couple days ago to help us with that. I'm going to sketch a quick graph here. Our zeros are negative 3, let's say like right there, and negative 2/3, which would be about here. I'll just label it in case. Now this is just a quadratic. That makes it a little easier, right? Quadratics, we know what they look like. They're just u's. And since this is a positive leading coefficient, it'll open up. So it's going to look something like that. Okay, this is what we did all of last chapter, right? Now we're going to transition and use some of the newer methods for factoring to solve a polynomial. Okay, remember how we had 5 different methods for solving a quadratic? We don't have that anymore. For polynomials with degree 3 or larger, there are really only 2 methods for solving. Factoring with ZPP, and then graphing and using synthetic division. We're going to focus on number 1 today. Alright, so let's try it in this problem. It says solve the following polynomial. I don't know what's wrong with me today. And then sketch the corresponding function's graph. So to solve this polynomial, the first thing we got to do is factor it. Because again, we're solving by factoring, right? Now think back to what we talked about yesterday. When it comes to factoring, we have a few different methods. We have sum and difference of cubes, we have difference of squares, we have grouping, we have trinomial. So you got to figure out which method to use. This one has 3 terms. That tells me I'm going to factor it using the guess and check method. Alright, since it's an x to the 4th, that means I do x squareds at the beginning. And then I got to find some numbers that are going to give me 36, and insides and outsides are going to give me negative 13. Well, 36, you might have to list them out, but I know that 4 times 9 is 36. And 4x squared and 9x squared can give me 13x squared if they're both negative. So, both negatives. Okay. But now we got to remember what else we talked about yesterday. And what else we talked about is that sometimes you can keep going, right? In this one, both of these are actually difference of squares. Did you notice that? It's okay if you didn't, but right now we should start getting into the habit of checking if you have anything left that you can factor. Right? Since both of them are difference of squares, I can factor both of them. X plus 2 times x minus 2. And then x plus 3 times x minus 3. So this is the completely factored form. And by being able to completely factor it is really helpful because then it makes solving so much easier. All right, because to solve this, all I need to do is set each one of these factors equal to 0 and solve. All right, so I'll get -2, x minus 2 equals 0. That'll give me +2. I know this is a little all over the place, my fault. Set the next factor equal to 0 and solve, -3. And set the last one equal to 0 and solve, +3. So those are my 4 answers. Do you remember talking about how the degree of your polynomial tells you how many zeros you'll get? So that's kind of your hint as to whether you found the right number. Okay. When it comes to sketching the graph, we're going to take these zeros, and they're the x-intercepts that we plot, so -3, -2, 2, and 3. And I'm going to go ahead and draw my graph. Now, this is a positive leading coefficient, so it's going to end up. All of these are individual factors, nothing squared, so no bounces. So I can just kind of go straight through the points, and it's going to end up at the other end too, since it's even. And there we have it. 4 answers. There's my graph. All right, let's try another one where you have to factor it a little differently. Okay, solve the following polynomial and sketch the corresponding function's graph. So again, remember, in order to solve, we are going to be doing this by factoring. Think back to last chapter. In order to solve by factoring, it does have to equal 0. That's still true. So I'm going to subtract this 81 over so that it's going to equal 0. That's the only way for the 0 product property to work. All right. Once I do that, now I'm going to try and figure out what type of factoring to use. So there are 2 terms here. That means it's either a difference or sum of cubes or a difference of squares. This isn't cubed, so I think it's going to be a difference of squares. All right, since it's x to the 4th, I'm putting x squareds there. Square root of 81 is 9, so +9 and -9. But wait, take a look at this. That looks like another difference of squares. So we're going to keep going. Okay, remember, sum of squares don't factor, so I leave that alone. But a difference of squares I can factor. All right, this is as much as I can factor it, so that means it's time to start solving. So to start solving, I'm going to set each one of these factors equal to 0, and I'm going to solve. Some of them will be easy to solve. Like in the last problem, they were all easy to solve, right? In this problem, a couple of them are easy. I get -3 and +3. But for this one over here, I got to be really careful. To solve this, I'm going to have to solve using square roots. So I'm going to subtract that 9 over, and I get x squared equals -9. And then remember this from last chapter, square root both sides with a plus or minus. So I end up with x equals plus or minus the square root of -9. Well, remember, -9 means I root 9, and the square root of 9 is 3. So this is actually x equals plus or minus 3 times I. So we're using a lot of what we did last chapter in this unit. So make sure if you had any questions from last chapter, you get them answered at some point so that you don't fall behind in this chapter. Okay. Last thing we're going to do, sketch the function's graph. I only have 2 real zeros, +3 and -3. Remember, imaginary zeros don't go on your graph. So just these 2 zeros. It is an even degree function and it's positive. So they're both going to end up. And since each of these zeros only appears once, there's no squared, I'm just going to connect them like this. Kind of looks like a quadratic, right? Sometimes that happens. And that's it. All right, everyone, let's try another one. Go ahead and flip your page over, and let's take a look at the back. So same kind of thing. Solve the polynomial, then sketch the corresponding function's graph. The difference here is if you take a look at number 1, it has 2 terms again, but we have c cubed. So when you see that cube, that tells you that you're going to be dealing with either your sum or your difference of cubes formulas. All right, since this is a plus, I know I'm going to use my sum of cubes. So for this first one, I'm using this one right here. Right? Now, it equals 0 already, so I can go ahead and get started. There's no GCF that I need to take out. So I'm going to find A and B, and then substitute those values into my formula. Right? A would be whatever cubed would give me x cubed, so that would be x, or 1x if you want to think of it that way. And B is whatever number cubed will give me 27, and that would be 3. So I can go ahead and factor this, again, just by using the formula up there. A plus B, so x plus 3. And then x squared minus x times 3, so 3x. And plus 3 squared, which is 9. And remember, we've talked about this before with the sum and difference of cube formulas. This part right here is not going to be factorable anymore. So we're not going to be able to factor that. And that's why these problems are actually a little bit more complicated. So since I'm done factoring, I would go ahead and use zero product property and start solving. All right, I would say, all right, x plus 3 equals 0. And I would solve that. That's x equals negative 3. And I would set this quadratic, this whole thing, equal to 0. X squared minus 3x plus 9 equals 0. The problem is that now I have to solve this quadratic, and I know that I can't factor it, and I also know that I can't use square roots like I did in the last problem. So really the only way, or the easiest way that I have to solve this quadratic is going to be to go back and use that quadratic formula. So remember when I told you it was important that you know it? Still important that you know it. Alright, quadratic formula, I need to know A is 1, B is negative 3, and C is 9. And I'm going to plug it in. So quadratic formula, that's negative B, so negative 3 is positive 3. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I'll just simplify. Alright, x equals 3 plus or minus. I'm going to use my calculator to help me out for a piece of this. Oops. If it's working. There we go. Negative 3 squared minus 4 times 1 times 9. Alright, negative 27, so we have the square root of negative 27 divided by 2. Off to the side here, I'm going to do square root of negative 27. Well, that's I times the square root of 27. And 27 can break down. So we end up with x equals 3 plus or minus 3i root 3 divided by 2. And I can't simplify these three numbers here, the triangle of numbers, so that's going to be my answer. Now remember before I mentioned how the degree can tell you how many solutions you've got. Well, the degree is 3 here. So since the degree is 3, I should have 3 solutions. I've got 1 right here, and then because this is plus or minus, that means I have 2 more. So those are my 3 solutions. Okay, once again, these are the most challenging because you have to do a lot of work. You got to do all that quadratic formula. But the good news is that we've practiced that a lot because that's what half of our last chapter was about. So we should be able to do that. We just got to make sure you remember the quadratic formula. Oh, and then we still got to sketch the graph. Okay, negative 3 is the only real 0 here because these are imaginary with the I. This is a cubed root, so it should end, and it's positive, sorry, so it should end going up. It goes right through. Cubed roots usually have this kind of shape to it. Another way you could draw it, since there are 2 imaginary solutions, sometimes we draw that with like an extra loop in the graph, but without touching the x-axis. So a graph could look like this also. Either one of those is fine. Alright, that's all the examples we're going to do today. So go ahead and get started working on that worksheet. If you have questions, just try and circle them, try and use your notes as much as you can, and ask anybody in class who you think might be able to help you. Feel free to work together. Just make sure that you're attempting all these problems. You should be able to factor them, right? That part should be nice and easy because we've been spending a couple days doing that. The solving part, you just got to use your notes and go from there. Alright, I'll see you guys later.